This is a short video showing off our group project for EE1301. The primary goal was to show our proficiency in using the particle photon microcontroller and in creating small circuits. This project lasted roughly 3 to 4 weeks, depending on if you started early or not. The idea behind our project was to make a small RC car that could access hard-to-reach places and use cloud functionality to send data to an HTML website, effectively allowing the user to read temperature and light from far away. This project actually ran on 2 breadboards, one to control the car itself and handle sensing, and another as a controller board using UDP wireless communication. The main body of the car is composed of a small sheet of laser-cut wood to hold up the breadboard, 2 3D printed wheels, and 2 wheels of a motor kit. A servo is also connected to an axle that allows the 3D printed wheels to turn. The motors we used draw too much current for the microcontroller alone to power, so we also had to wire 2 AA 1.5 volt batteries in series to a motor driver board to provide the minimum voltage required to run the motors. The project is primarily programmed in C++ with a small HTML file to make cloud functionality run. One of the major issues we ran into was that UDP communications and cloud functionality interrupted each other if both were being run simultaneously. We were able to get around this limitation by having 2 different modes that would either take input from the website or have it detect input signals over UDP. With this, the sensors were able to upload to the cloud at any time, while also maintaining the ability to control the car either through the website or via the controller board. The code was able to switch modes dependent on whatever the user entered most recently. Overall, this project was great for learning how circuits can get large quickly, and how to combine code with them to be able to perform the operations we need. It was also helpful for understanding the importance of staying organized, as our wiring got very messy by the time our sensors were added. One more thing we learned is how important it is to consider every possibility when troubleshooting, as it took us a long time to realize small issues like our ground rail not being properly connected, and our USB cable powering the microcontroller being faulty. One of the most valuable aspects of this project was learning to problem solve without the guidance of a lab manual. Having all of the ideas be our own forced us to communicate on what we wanted the project to look like, and required us to try and stay organized to create a project that anyone could look into, understand, and contribute to.